Oftentimes we store chemical solutions in a more concentrated form. Not unlike when you go to the grocery store, you can buy concentrated orange juice, right? It saves on space. So when we have concentrated solutions, these are called stock solutions. They're kept in stock, in the stock room, managed by the stockroom technician. And so to use that concentrated solution, we need to add more solvent and dilute the solution. And this is the same idea as making orange juice from the frozen concentrate. We add more solvent. With the orange juice, the solvent's going to be water. Many of these solutions that we use in the chemistry lab, the solvent is water, but not always. What's important to remember is the amount of solute, the stuff dissolved in the solution, does not change when you dilute a solution. Think about that can of orange juice. You know, it's full of orange goodness, right? When you empty that into the pitcher, assuming that you empty it completely, all the orange goodness that was in the can goes into the pitcher. You add water. Adding water does not change the amount of orange goodness in the pitcher, right? It just dilutes it. It changes the concentration. The amount of solute, the stuff dissolved, stays the same. All we're changing is the amount of solvent. So what that implies is that the moles of solute in the first solution are going to equal the moles of solute in the second solution, because all you've done is add water. And that's where we get this equation, M1 times V1 equals M2 times V2. The concentrations and volumes of the stock solution and the diluted solution are inversely proportional. So this is the molarity of the first solution times its volume, and that's equal to the molarity of the second solution times its volume. The concentration changes, the volume changes, the amount of solute does not. So let's think about this for a minute. If you understand where this comes from, it's so much easier to remember. What's the unit on molarity? Moles over liters. Okay, so that would be the unit on M. And volume, a unit could be liters, right? So if we multiply that by the unit in volume, this unit, what do we end up with? Moles. So what this equation is doing is saying the moles of solute in solution 1 are equal to the moles of solute in solution 2. We're going to use this equation to do dilution calculations. Here's an illustration of how you might dilute a solution, and we're going to do this in lab tomorrow. So what are we doing here? We are making a 0.5 molar solution out of a 10 molar solution. So the concentration is going down. So we're measuring out 0.150 liters of this 10 molar solution, and we're putting it into a volumetric flask. And then we're going to add water to the mark so that we have a volume equal to the volume specified on the flask. And so the concentration, here's the concentration of the stock solution times the volume of it that we used. And that will be equal to the concentration of the new diluted solution times its volume. Okay, so usually what happens when we do a calculation, get the right number of fingers, 4 variables, right? M1, V1, M2, V2. We're going to know 3 of them, we calculate the 4th. Let's do an example. Isotonic saline is 0.15 molar aqueous sodium chloride. Blah, blah, blah. How would you prepare 0.80 liters of isotonic saline from a 5.0 molar stock solution? So we have 2 solutions. We need to keep them straight. Sometimes people have trouble with that. Let's call this isotonic solution. We're going to call that number 1. And we're going to call the stock solution number 2, just to keep them straight. Okay? So we're looking for molarities and we're looking for volumes. So here we have 0.80 liters of this one that we're calling number 1. So that's the volume. We'll call that volume 1 is equal to 0.80 liters. Do we know what the concentration of that solution is? Look at the beginning of the problem. Isotonic saline is 0.15 molar aqueous sodium chloride. This is talking about the same solution. This is the concentration. So that's the capital M1 is 0.15 moles per liter. What do we know about the stock solution? We know its concentration, right? So this is capital M with a subscript 2, and this is 5.0 moles per liter. They're asking, how would you prepare this isotonic solution? We need to know how much of the stock solution to add, right? So we break out that equation, M1 V1 equals M2 V2. And what are we going to solve for? We're going to solve for the one we don't know. We don't know what V2 is. So we're going to solve for V2. This is algebra. And we're on Chem 1A, so I'm going to go over this really quickly. We need to get V2 by itself. We're going to divide both sides by M2. These guys can't cancel out. We find that V2 is equal to M1 V1 over M2. Sometimes students want to put the numbers in there and then rearrange things. I really don't recommend that. Now let's plug in our numbers. Always include the units, okay? Because sometimes we're going to have to fix up the units, and if we don't write them into the equation, we might not notice. So M1, 0.15 moles per liter. V1, 0.80 liters. M2, 5.0 moles per liter. Look at the units. Well, we have moles per liter on the top and moles per liter on the bottom. Those guys are going to all cancel out. We're left with a unit of liter, which is a perfectly good unit of volume. And so we find that the volume is 0.15 times 0.8 divided by 5. How many significant figures should there be? 2. This only has 2, and this one has 2, and that one has 2. So we're going to say our volume is 0.024 liters. Anybody else get that number? Okay, thanks. Now, writing down, oh, that's V2. Writing down V2 equals 0.024 liters, does that answer the question? No, the question is, how would you prepare the solution? It's part of how you prepare the solution. I'm not going to write this out, but you might say, I would measure out 0.024 liters of stock solution, add it to a volumetric flask of, well, actually, you're not going to find a volumetric flask that size, but I would add 0.24 liters of the stock solution and dilute it to a total volume of 0.80 liters. Doesn't have to be long and elaborate, but that's describing. Really important thing, it's kind of a life skill, really, is learning to answer the question that's asked. And I see in a lot of student papers and a lot of people, stuff they write, great stuff, doesn't answer the question, okay? So not a good way to make an impression. Any questions on that one?